Welcome to one of the world's most advanced robotic prosthetic manufacturing facilities. It all begins with the arrival of meticulously selected raw materials, medical-grade titanium, carbon fiber composites, and precision electronics that will soon become life-changing limbs. Every component undergoes rigorous quality screening. In this high-bay warehouse, guaranteeing that only the finest materials advance to production. In the laboratory, titanium alloys and carbon composites are tested to extremes, for strength, fatigue resistance, and biocompatibility. On the machining floor, multi-axis CNC centers sculpt titanium into lightweight, ultra-strong pylons and joint components with micron-level accuracy. Skilled technicians perform the art of carbon fiber layup. Layer by layer, pre-impregnated sheets are placed by hand and machine, creating structures. Sealed under heat and pressure in massive autoclaves, the carbon fiber cures into rigid, energy-storing blades and frames that will one day power fluid, natural movement. Once cooled, excess material is precisely trimmed, revealing the sleek, aerodynamic forms that define modern lower limb prosthetics. In the additive manufacturing farm, patient-specific sockets are printed with biocompatible resins, tailored to the exact anatomy of the individual who will wear them. Medical-grade silicone is carefully mixed and poured to create lifelike cosmetic coverings, complete with subtle veins and natural skin tones. In a sterile electronics clean room, surface mount robots assemble the intelligent heart of the prosthetic, myoelectric sensors, microprocessors, and wireless controllers. Powerful yet compact brushless motors are individually calibrated, ensuring silent, responsive movement in every finger and joint. Advanced lithium polymer batteries are integrated with smart charging circuits, delivering all-day power in a lightweight, safe package. Structural assembly begins as titanium meets carbon fiber in perfect alignment, hybrid designs that combine durability with dynamic energy return. Sophisticated microprocessor-controlled knees are integrated, programmed to adapt in real time to walking speed, terrain, and even stumbling. Energy-storing foot blades are bonded, creating a spring-like response that helps users walk, run, and even play sports with confidence. In the upper limb zone, delicate finger segments are linked with tendon cables and micromotors, capable of dozens of natural grip patterns. Modular wrists and elbows are added, offering powered rotation and flexion guided by the user's own muscle signals. Myoelectric sensors are precisely positioned to detect the faintest muscle signals from the residual limb, translating thought into effortless motion. Finally, lifelike silicone gloves are fitted, restoring not just function but appearance, often indistinguishable from human skin. The complete limb comes together, mechanics, electronics, and cosmetics united into a seamless, intuitive extension of the body. Wiring harnesses are carefully routed and secured, ensuring reliable communication between brain, muscle, and machine. Power is applied for the first time. Motors hum quietly to life as engineers verify every system responds perfectly. Joints are calibrated across their full range, fine-tuning resistance and speed for the smoothest possible gait. Grip patterns are tested, from delicate pinch to powerful grasp, all triggered intuitively by the user's muscle signals. Durability is proven through millions of simulated steps, confirming these limbs are built to last a lifetime of daily use. Advanced models undergo waterproof testing, emerging fully functional, ready for showers, swimming, and everyday life. Cosmetic artists add the finishing touches, freckles, tones, and textures matched to the user's own skin. In the on-site biomechanics lab, prototypes are worn and analyzed, ensuring every movement feels as natural as possible. Hands are challenged with complex tasks, proving they can tie shoelaces, hold a coffee cup, or play a musical instrument. Power systems are validated for real-world endurance, with rapid wireless charging for minimal downtime. Custom firmware is installed, allowing clinicians to fine-tune sensitivity and grip strength to each individual's needs. Behind the scenes, waste is recycled, machines maintained, new innovations developed, and the next generation of engineers trained. Only after rigorous final approval does a prosthetic earn its place in someone's life. Even the rare imperfection is swiftly corrected, reflecting the facility's commitment to perfection. As the final truck departs, another batch of advanced limbs begins its journey, restoring possibility, one precision-engineered component at a time. This is more than manufacturing. This is the creation of freedom, built with science, precision, and care. The future of human potential, made here. Packaging sequence, padding, manuals, labeling. Each device is carefully packed with accessories, chargers, and detailed guides, ready for delivery to clinics worldwide. From climate-controlled storage to secure global shipping, every step ensures the prosthetic arrives in perfect condition, often within days.